This is 3.6, more factoring and graphing. Your essential question, how do you use factoring to help graph? For examples 1 through 3, factor each function completely over the integers, find all the roots or zeros, and sketch. One thing you'll notice, we might have imaginary roots in this chapter, so I'll talk about what to do with that, or this section. So, you got to factor it first. 4 terms, check for a GCF first, no GCF. Grouping, okay? So f of x equals, that first group has x squared in common, with an x plus 4 left. The second group has a negative 9 in common, an x plus 4. Don't forget the negative changes all the signs. Okay, and now look, we have to have the same binomial. If you don't, you can't factor that way, don't forget. So in this case, we do have the same binomial. So I have x plus 4, and then x squared minus 9 left, and now we are multiplying them. And then it factors more. Difference of squares, right? X squared, 3 squared. So it's x plus 4, x plus 3, and x minus 3. Factored. Okay, we need in behavior. So my degree, my lead coefficient, and my in behavior. Remember, you can use the factored form or the initial form. I like going to standard form because you just look at the highest one, highest degree. So it's third degree. Coefficient of that was positive 1. Odd positive, down up. Okay. And then we always need our x-intercepts and y-intercepts, with x-intercepts with their multiplicity. Okay, so set each thing equal to 0. Hopefully you're getting good at this by now, recognizing things. Okay, so I get x equals negative 4, negative 3, and 3, positive 3. That they all end up with a multiplicity of 1 because we look at the exponents. Those factors all have a 1 exponent. They all curve once. And then finally your y-intercept, set x equal to 0. Okay, so y equals, remember f of x is the same as y. 0 plus 4, 0 plus 3, 0 minus 3. Okay, so I get 4, positive 3, negative 3, which gives me a total of negative 36. So 0, negative 36, that is my y-intercept. Okay, so this is practicing. This one is the same, really, as what we've been doing. Start low, cross, cross. Should probably do a little better than that. How is this going to work? Okay, cross, 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 cross. Doesn't look great, but that's okay. Okay, and there we have it. It says find all the roots and zeros, and we did. They are all real. Real roots we graph. Okay. Example 2. First, we check for a GCF between all the terms. Nothing in common, so it's 4 terms. That means we're grouping again. So this time I get y equals, the first group has 4x squared in common. So x plus 5. Second group has negative 9 in common. Also x plus 5. Remember, it has to be the same. If it's not, something's wrong. So I get x plus 5, 4x squared minus 9. Okay, so difference of perfect squares again. 2x squared is 4x squared. 3 squared is 9. And so we get, it's not quite as nice as some people are used to. And it's not always going to end up super nice. Okay, so that's factored. Look at our degree and our lead coefficient, which gives us our in behavior. Degree, going back to my original thing, right? Standard form, that's what I like to look at. The exponent is 3. Lead coefficient is positive 4. It does end up down up again. You need to know how to pick that out. using your degree and lead coefficient with that chart. Okay, so we need our x-intercepts. Set y equal to 0. Oops. So the first one's easy. The next two take a couple extra steps, right? We're going to end up with fractions, actually, on these. So you will, every once in a while, end up with fractions. So negative 3 over 2, add 3, and I get positive 3 over 2. Okay, so negative 5, 0 with a multiplicity of 1. Negative 3 over 2, 0 with a multiplicity of 1. And positive 3 over 2 with 0 with also a multiplicity of 1, right? Multiplicities are the exponents. Everything else is the same. So 3 over 2, 3 divided by 2 is 1.5. Make sure you know that for graphing. That's going to help. Y-intercept, plug in 0 for x. So I get y equals 0 plus 5, 2 times 0 plus 3, and 2 times 0 minus 3. Okay, so I get 5, or anything times 0 is 0, so it's 0 plus 3, which is 3, and 0 minus 3, which is negative 3. So I get negative 45. 0, negative 45. That is my y-intercept. Graph them. 1, 2, 3, 4, 5. 1.5. Trying to be as accurate. Positive 1.5. And negative 45. It's down up, so here we have it. Okay. So I'm going through these pretty quick because most of it's the same. Just making you recognize it's not always going to be super nice numbers. That's kind of what we're introducing in Objective 6. It's not always going to be nice numbers. All right, y equals f of x, which is x cubed plus 3x squared, minus g of x. Remember, we're minusing the whole g of x. That means we need to distribute the negative across. So everything changes sign. So it's plus 4x plus 12. GCF first, there isn't one. Grouping. So x squared, x plus 3, positive 4, x plus 3. So I end up with x plus 3, x squared plus 4. So you have to recognize this. We can't factor this more. They are perfect square numbers, but it has to be a difference of perfect squares to deal with that. Okay? So be careful about that. So we look at our degree, our lead coefficient, and our end behavior. My degree, I go back to my original function. It's third degree, positive 1, down, up. It happens to be all down, up. That's only because they're the easier ones to write, honestly. So that's why that's how that ends up on my notes. Don't just assume it's always down, up. So I set y equal to 0. This is an interesting one. Okay, the first one's easy. I'm just going to do that one first. Subtract 3, x equals negative 3, 0 with a multiplicity of 1. The next one, I subtract 4 from both sides, and then I square root both sides. Whenever we square root both sides, what do we remember? Plus or minus. Okay, so I get x equals positive, oh, the square root of negative 4. That's an imaginary thing. Square root of 4 is 2, but it's negative, so 2i. And I also get negative 2i because it's square root both sides. I get the positive and the negative because of both of them, if I plugged it in, would be true. Since it's squared, negative times a negative makes a positive, so be careful about that. These I'm not going to write as points. They are roots. It asks us to find all the roots. That means all the x values. Okay, remember, roots match the degree. They're a multiplicity of 1. Each one occurs once, so I have 3. 1, 2, 3 roots. It matches the degree. But I only have one x-intercept. imaginary numbers do not graph as x-intercepts, only real solutions. So I have 3 solutions, but only 1 x-intercept. Okay, y-intercept, plug in x of 0, so I get 0 plus 3, 0 squared plus 4, so I end up with 3, positive 3, times positive 4, which is positive 12. That one's the same as normal. So I have negative 3, I have 12. Okay, I'm going to show you something here. The imaginary solutions create at the valuation, so without the I, so at 2 and negative 2, they create slight curves in the graph. Okay, so at positive 2, it's going to be up a little higher, and negative 2, those 2 points about, it's rough, I don't know exactly where, it's a sketch, don't forget, we're going to have slight curves, so it's going to look something like this. And if you go on to Desmos, you'll find something that looks actually more like this. Okay, that's kind of what imaginary solutions do, is they add in these little curves to the graph that aren't x-intercepts, but they add in little slight shifts, okay? So keep that in mind when you graph it. Don't draw a line. It's not a line, right? That's not what a third degree polynomial looks like. And you can kind of figure out about what it looks like based on the x values of your imaginary solution. So around 2 I curved, or around negative 2 I curved, and then around positive 2 I curved again. And I got my solutions. Okay? One thing on your homework you need to remember, SOAP method. So just on the side here, remember that is sum or difference of cubes. So perfect cubes numbers. And so that's if you had a cubed plus b cubed, you end up with a plus b, a squared minus ab plus b squared. Remember SOAP, that is same. Oops, sorry. We look at our sign, it's the same, opposite, always positive. That's why we call it the SOAP method. And if you had a cubed minus b cubed, that's a minus b, a squared plus a times b plus b squared. Same, opposite, always positive. Okay, where a and b represent the cube root of whatever those numbers are. So those are going to show up, and you need to know that. Also, to be able to find these solutions, you need your, so I'll highlight this thing, because that's one thing you need to remember. The other thing you need to remember is your quadratic formula, which I'll write out on these notes for you to remember. If you don't remember it, you could, or how to use it, you can go back to previous lessons, previous videos. So x equals, remember a, b, and c represent the coefficient, the numbers in front. A is in front of x squared, b is in front of x, and c is always on its own. Sign is important, so it's opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. And once again, if you need to go back and watch a video because you don't remember how to use that, you need to, because this is something you need to know for this unit as well. SOAP method and quadratic formula. So last one, it says, write in factored form the equation for a polynomial function given, oh, typo, f of x, is a polynomial, oh, no, sorry, p of x, follow your letter. P of x is a polynomial such that p of negative 1 equals p of 2 equals p of 3 equals 0, and p of 1 equals negative 4. So this is just a quick review. So remember, p of x equals a, because we got to find the a value, it wants the equation, meaning we're going to have to plug in. And I need the factors that give me these zeros, negative 1, positive 2, and positive 3. So it's x plus 1, x minus 2, x minus 3. It's always the opposite sign of the actual x-intercept. Then we have this. We have x and y to plug in. P of x is just y. So I get negative 4 equals a, 1 plus 1, 1 minus 2, 1 minus 3. So 2, -1, -2. Remember, negative times a negative makes a positive. So I end up with positive 4a, divide, a equals -1. So p of x equals -1, x plus 1, x minus 2, x minus 3. Just a quick review how to write out functions if you need to. Don't forget the equation, you have to plug in the extra point to get the exact a value. If it's an equation, that's when you get to just look at the in behavior and figure it out. Okay, so be careful about that. Make sure if it's the equation, you plug in the extra point. All right, with that, it's a lot of information in a small little set of notes. You have a 3-sentence summary